Okay, last one for today. Let's take a look at exercise 9. Now, exercise 9, it's not going to look that different than what you've seen already. However, the one thing that we need to talk about is the strong acid. We've talked about this a little bit before in class, but when you come up and look at these, you need to have the understanding that strong acids 100% dissociate in water. So what that means is this. Let's take this HNO2 or HNO3 here. So HNO3, when I put this in water, or we have it in solution, this H plus ion is going to dissociate, and this NO3 is also going to ionize, okay? So dissociate, ionizing, same thing. We're going to have this go into solution, and the ions will form separate of each other. So what that means is this. If I start off with 0.1 molar of this, that 100% of this is going to separate, and I'm going to have 0.1 molar hydrogen ion and 0.1 molar NO3 minus ion, and 0 of this, okay? After dissociation, after we put this in water, 100% goes that way. Later on, when we start talking about weak acids, we're going to have some of this remain and stay together. In fact, a lot of times we'll have a lot of this thing together. So whenever you're given the concentration of a strong acid, the concentration of that acid is going to become the concentration of the hydrogen ion, okay? Because none of it is going to stay in this form where the acid, the hydrogen, is attached to the anion. All right. So calculating the pH of 0.1 molar HNO3, okay? We've done this a bunch of times by this point, so we'll take the negative log of 0.1. Okay, and we get our pH of 1.0. Okay, so here's our pH of this one. All right, and now we have a smaller quantity, much smaller, okay, of hydrochloric acid. So 1 times 10 to the minus 9th. Okay, just wrap your head around that. That is 9 zeros with a 1 at the end of it. So 0.00000000001. Okay, so really small amounts. Okay, and negative log. Make sure I have the right value. Okay, and we get a pH of 10. Okay, so pH here equals 10. So while we have two acids, this one shows up in acidic range. This one here would actually show up in the basic range. Okay, and you ask, well, how can that be? Well, remember, this is the amount of hydrogen that's going to be part of a pair. Okay, so our Kw matches our OH concentration to our H plus concentration. And that's going to equal 1 times 10 to the minus 14th. Okay, if either one of these is really small, okay, we're going to have the other one be slightly bigger. So that's how we can have something that we put a little this is such an incredibly small amount of hydrogen into a solution and still have it being basic. Okay, so whenever we're talking about a solution being acidic or basic, we're really talking about the balance between the hydrogen ion and the hydroxide ion, and as it relates to the Kw for water. Now remember, this is 1 times 10 to the minus 14th at 25 degrees, which is our standard for Kw.